So today we are going to put all of the factoring that we've done so far together. Okay, we've talked about 7-4, where we looked for a greatest common factor. Okay, we took those out. And then we worked on 7-5, where we were factoring a trinomial. The difference with these trinomials is now you're seeing this ax squared. You're going to now have a coefficient in front of the squared term. Okay, and so we're going to apply that divide and slide rule. Okay, so for example, I might ask you to factor 3x cubed plus 15x squared minus 18x. So you're still working with a trinomial. Definitely. What's different about this trinomial? It's a cube, right? What we want to look at, and what our first step is we need to get in the habit of, and we're not yet there, but we want to look for or take out, I'm going to say look for a GCF. Is there a greatest common factor that exists? Yeah. And when I look at all three of these, what do they have in common? What divides into all of them?
3.
A 3.
And an x.
And an x. So the greatest common factor is 3x. So I want to take that out first and then see what's left. Okay, remember when we take that GCF out, we are dividing each one of these pieces by that GCF to see what's left in the parentheses. So the 3's would cancel here. Be left with an x squared plus a 5x minus a 6. Now I want to take this trinomial that's left and I want to see if I can factor it. James?
What if that 5x was squared?
No, because it's squared, but I took out an x. So when I divide here, I subtract the powers and I just have x to the first left. Okay? And remember, you can check your work when you take out the GCF by distributing 3x times x cubed is supposed to be, or x squared is supposed to be a 3x cubed. 3x times 5x will give me the 15x squared. 3x times the negative 6 will give me the negative 18x. Okay? So, but I do want to look at this now. This trinomial, does it factor? Is it going to break into two binomials? Okay? If we apply the divide and slide rule, so then I'm going to say step 2 is going to be factor the trinomial. Some of you won't need to use divide and slide here. This has a leading coefficient of 1, so maybe you don't want to use that. You might want to just say x. We'll start both of these out with x. If I did use that divide and slide rule, I would be multiplying the leading coefficient, which is a 1. There's a 1x squared, times the last value. That's a negative 6. And my middle term is a positive 5. So I want to come up with values that when I multiply, I get negative 6, but when I add, I get a positive 5.
Negative 2 and negative 3.
I put a negative 2 and a negative 3 in there. Would those multiply to give me a negative 6?
No.
Nope.
Positive 6.
Say it again, Noah.
They give you a positive 6.
Correct. So we can't use those.
6 and negative 1.
6 and negative 1. Positive 6, negative 1. When I multiply those, I get the negative 6. When I add, I get the positive 5. So plus 6 minus 1. And then again, with that divide and slide rule, we can't forget to divide by that leading coefficient. But in this case, when it's a 1, those values do not change. So we're going to get x plus 6 and x minus 1. And that's completely factored. We took out the greatest common factor here, and we factored the trinomial that was left. Okay, you might want to look at 5x squared minus 35x plus 50. Is there a greatest common factor?
5.
Okay, we're going to take 5 out. So since that's the greatest common factor, I'm dividing each of these pieces by that greatest common factor. So I'd have an x squared left minus 7x plus 10. Okay, we don't want to stop there. We want to see if the trinomial then will factor. I use my divide and slide rule. This is a 1. I'm taking 1 times 10. And I have a negative 7 in the middle. So what can I multiply and get positive 10? But add and get negative 7. Negative 5 and negative 2. This is going to be x minus 5, x minus 2. We divide by the leading coefficient. Will it change those values when I divide by 1? No, so I'm just going to stop there. Now let's see some that you don't have a leading coefficient of 1. So you might be asked to factor 2x squared plus x minus 21. Notice that my leading coefficient is not a 1 anymore. Okay, do these 3 terms have a greatest common factor?
No.
Do all terms contain x?
No, they don't.
No. So x is not part of the greatest common factor. Is there something other than a 1 that divides into a 2x squared, a 1x, and a negative 21? No. So there's no greatest common factor. That doesn't mean we can't factor it though. So we just go to the second step, which is to factor the trinomial. This time I want you to make that x. Even if you didn't use the divide and slide rule before, I want you to use it today. I look at the first number, the leading coefficient, and the last number. And I'm going to multiply those together. So what's 2 times a negative 21?
Negative 42.
Negative 42. And what's my middle coefficient?
X.
1.
Positive 1. So I'm looking for 2 numbers that when I multiply, I get a negative 42. But when I add, I get a positive 1.
Negative 6 plus 7.
Negative 6, positive 7. Okay, so we take our 2 binomials. It's going to be x minus 6. X plus 7 is how I start. This is not your answer yet. That's how you start it. And what do I have to divide by? Okay, we go back to that leading coefficient and we divide the numbers by the leading coefficient. This is where you get the divide and the slide part. We haven't had to slide yet because everything has been divisible by 1. Does 6 divide by 2 evenly?
Yes.
Yes. So I go ahead and I do that division. 6 divided by 2 is 3. How about 7 divided by 2? Does that divide? No. And here's one thing you have to have. That fraction has to be in lowest terms. So if that fraction's not in lowest terms, you need to reduce it before you slide. Because it doesn't divide, we slide that to the front. We get 2x, and we leave the numerator where it's at. And we say 2x plus 7. Because it didn't divide, we have to slide. Now, if I were to FOIL this to check my work, which we should always do, first term times first term, x times a 2x, is that going to give me a 2x squared? Yes. Outside product would be a positive 7x. Inside product would be a negative 6x. Does that combine to give me a positive 1? Yes. Last term times last term give me the negative 21?
Yeah.
Yes. So this is our answer right here.
Come on.
10x squared plus 3x minus 1. Look for a greatest common factor first.
There's no.
There's one.
There isn't one, that's right. So there's no greatest common factor, so we're just going to go right into our divide and slide. We take the leading coefficient times the last number. And if there's another variable here, we're just taking it times the number itself. So 10 times negative 1, negative 10. And the middle coefficient is a positive 3. So what two numbers can I multiply and get negative 10? But when I add them together, I get a positive 3. 5, negative 2. I'm going to say x plus 5, and I'm going to say x minus 2. Don't stop here, because if I stop here and I FOIL, I am not going to get first term times first term is not 10x squared. Okay, you've only found the two terms. We now have to divide by the leading coefficient. So I'm going to divide these by 10. Does this divide evenly?
No.
No. Okay, it's a fraction. Before you slide, the fraction has to be in simplest form. So 5 over 10 reduces down to what? 1 half. Now I slide. So I'm going to slide that 2 to the front and say that's 2x plus 1. Does this divide evenly?
No.
No, it's a fraction. So I have to reduce the fraction. What's 2 over 10 reduced down to? 1 over 5. Have your fractions in simplest form before you slide. It doesn't divide, so the 5 slides to the front, and I leave the numerator as the 1. And then check. First term times first term. 2x times 5x. That's where my 10x squared comes from. Outside product's negative 2x. Inside product's a positive 5x. That's where that positive 3x is coming from. Last term times last term is your negative 1. There's my two factors right there.